Welcome back to the Pre-Vetted podcast, where we spotlight extraordinary people and remarkable talent reshaping our world. Today, we're joined by Joseph Cao. He has a PhD and is the CEO and co-founder of Magnify, a Stanford spinout working on predictive maintenance for critical power infrastructure using high-frequency magnetic sensing plus edge AI, with the goal of earlier and more accurate failure detection for operators like data centers and utilities. Before Magnify, he led hardware and materials work across Meta and Apple, including managing an R&D team commercializing optical materials for Apple Vision Pro and next-gen AR and VR. He's also an active angel investor throughout Kalford One, backing deep tech founders in energy, climate, AI, and robotics. And he earned a Stanford GSB MSX, where he was a Stanford Impact Founder Fellow focused on climate entrepreneurship. Joseph, welcome to the show.
Thank you, Federico. Really appreciate the opportunity to be here.
I am honored to have you here today. So let's start by talking about what Magnify is.
Yeah, so you summarize actually really well. So we do predictive monitoring for critical power asset to prevent very catastrophic failures. For example, we have transformers, inverters, power cable in the utility grids, in manufacturing sites, in data centers. They're very critical for the power deliveries. What we do is to use our sensor and predictive AI predictive monitoring platform to unveil early anomaly and signals and the insights months ahead of time very accurately to help the asset operator intervene very early with the maintenance and operations to prevent costly outages. So, for example, this may be very important for someone like data center, our utility grids, any mission critical assets.
Right. Very interesting. Yeah, because with vibration, you can detect the failures before they happen so people can have more planning ahead. In particularly infrastructure, it's so reliable that everything works until it doesn't, right?
Yeah.
Unless they follow a rigorous maintenance plan, which most people don't, right? Most organizations don't. I think that's a very interesting problem to solve.
Yeah, exactly. And in fact, in the US, we have 70 million transformers in the grid or in the mission critical facilities behind the meter, but 65% of them are reaching the end of life, meaning they're pretty much like time bomb in our facilities. They can blow up a lot of times. Usually the average life is around 40 years, but a lot of them are very even older than that. So it's definitely a problem in our aging power infrastructure. We're going to see a lot of replacement, especially for transformers in the next decades or so.
Right. I understand they work okay until they start running out of oil. They have a little leak, and then it goes super quickly goes down. Right?
Yeah, and you can replace the oil. Actually, oil tells you a lot of problems inside the transformer. So people still use this dissolved gas analysis to assess the health of the transformer, but it's a chemical approach. I always use this analogy. It's like doing a blood panel, a blood test to detect heart attack, rather than using ECG. And with our approach, we're using a magnetic sensor, kind of like an ECG, but for transformer or any electrical assets. So we directly listen to the heartbeat so that we can give very direct, accurate, and early insights about the health of any electrical equipment to prevent this type of failure.
So what made you start Magnify? How did you get into this problem set?
Yeah. Very good question. Actually, I will make the story short, but it's actually related to my upbringing. So I grew up in Taiwan. I did a lot of neighborhood recycling, volunteering with my grandparents, and my grandma always taught me that every piece of resource is very valuable if you can use them for the right purposes, even for trash or anything, right? So that inspired me to be a material scientist. I came to the U.S. to study plastic, polymer science and got my PhD from UC Berkeley. We invented a lot of biodegradable polymers, very unique polymeric materials, and that's what you mentioned. I contributed to many research and development projects in Dow Chemical, Apple, Facebook, and Apple was a transition point in addition to developing the Apple Vision Pro and the future smart glasses with my polymer expertise. I was also helping them to build this battery recycling program because Apple tried to really close the loop for their battery supply chain. And that just resonated with me on my original mission to study material science. I was really motivated by this idea of circularity, recycling, how to best utilize the existing resources. So I decided to come to Stanford to explore the energy industry. Started with this hypothesis on using battery for, say, data center energy storage to make our grid more resilient, and then use a very similar diagnostics technology, but pivoted for predictive monitoring for power assets. It's actually the same idea. It's always the same North Star that guided me throughout the entire journey. This idea about how we can best utilize the existing resources in the power infrastructure to provide a more resilient energy future. So from recycling or repurposing lithium-ion batteries to gaining earlier insights on this very important yet aging asset in our power infrastructure. So that's what motivated me to start this. And as I did deeper into this problem, that's kind of what I just shared. I realized that it's such an intriguing issue about, especially on transformer. It's a very important asset to step up and down the voltage to transmit for power transmission and distribution. But the problem is that, again, they are just getting very old. And also another important market pull is that the lead time for transformer is getting longer and longer. So it takes like years to replace a transformer. The supply chain has been very stressed. So that's because of all this, what I learned, my original motivation and everything I learned from my market research at school at Stanford, it really all came together in the past few years to help me build Magnify.
Right, right. That's amazing. I mean, I grew up in Argentina and moved to Mexico 17 years ago. And I had the same issue in Argentina. We could not find spare parts for vehicles. Sometimes I would have to make with other spare parts, build other cars, right? Or get used parts and just refurbishment, in a DIY kind of
Yeah,
situation. So
yeah,
I can see how that you know that is becomes an issue, right? I mean, in the US,
yeah.
it's easier to just uh, buy something new. The labor is so expensive than for for people they usually do that, right? But coming from an economy of scarcity, then you appreciate the the value of reusing and being able to refurbish parts, right?
Yeah. It's actually interesting. Refurbishing transformer is now a booming business in the US as well. So people will actually just change some parts inside the field transformer, and the lead time can be shorter in that case rather than buying
Right.
a new transformer. So yeah, it's also a very good example of a circular economy.
Yeah, I had a VW bus many years ago, and I was a broke student and couldn't get the parts to fix it. So the steering wheel has a block of plastic, right, a rubber, to reduce vibration on the wheel, and I could not find it. I could not get it. So what I did is I got milk boxes, and I cut them to the shape of the block, and then I did a sandwich with the existing rubber block that was kind of, uh, you know, the original shape kind of got lost, and it was not as hard as
Yes.
together. A lot of those, we paste them together, we put it on again, and it was amazing. I mean, it was almost as new, right?
Yeah, I
It
know.
worked. So, who need this most? I mean, residentials, data centers, utilities?
Yeah, so they all have very different in I would say perspective about our solutions, but I would say we have been working a lot with independent power producers. So these are the one who provide energy, power. They generate power using solar, wind, or even fossil fuels. But in the US, at least, a lot of the IPP, we call it IPP, independent power producers, their transformers or even inverters are getting very old. I think on average, the renewable projects are, say, 15, 20 years. Of course, there are a lot of new projects, but because we installed a lot of solar wind projects, say, a decade ago, and these projects are getting old, and they are getting worried about the aging transformers and the long lead time to replace them. And so these are from a lot of our market research and also customer engagement who are really eager to gain more data about their transformers so that they can plan for the replacement and avoid this type of outage on their aging transformers.
Right. I find this very interesting. So, what does your sensors measure?
So we are using a magnetic sensor called a Hall effect sensor and some other sensors. So it's actually a hypersensing platform, including this Hall effect sensor that we invented at Stanford. And this sensor is a magnetic sensor that measures the magnetic signal from any conductor. Say, for example, you have a wire coming from your appliances, in this case, the transformers, the inverter, switchgear. We can measure the magnetic field generated by the current flowing through that wire and translate that back to electrical information, in this case, the voltage. So it is a magnetic sensor, but people also use it for current sensing because the current flow actually generates magnetism around the. So that's why I call it we are kind of like listening to the heartbeat of the electrical asset because we literally measure the sine wave of the current flowing through any electrical equipment using this magnetic sensor.
Right, right. Yeah, I know those devices works like magic. It's amazing how they work. Yeah. And what does the AI has to do with the product? Are you processing the data?
Yeah. Yes, I think that's another thing I'm very excited about. So I think sensor only collects very high fidelity data, but how can you really synthesize the insights based on this data? That's where the analytics become important. Traditionally, classification of different types of failure used on the electromagnetic waveform is very poor, and hence people get a lot of false positive, and it's hard to understand the actual faults and how bad it is. So that's what exactly the first thing that AI does in our platform. So it actually does a great job on classifying the fault type and decouple the fault from the noise in the environment so that we can know what is the type of the fault and how bad it is. And a second layer of the AI that is doing is, in addition to our sensing data, if the operators are also collecting, say, the gas sample, the temperature, the pressure from the transformer, we can also use the AI to do data fusion to provide, we call it the dynamic health index, basically a holistic assessment of the health of this transformer, and even do the ranking of all the transformers the operators have to provide a very comprehensive view of the fleets, the health of the entire fleets of the asset. So in short, the AI is doing the signal classification and to provide the insights accurately without false positive. And the second thing is to do data fusion on multimodal data to translate all kinds of data into the actionable for the operators.
Interesting, interesting. The Because the issue is false positives, right? Having false positives kind of uh,
Yeah,
reduces the trustworthiness of the.
exactly.
Uh, have you done a comparative analysis between assets? Kind of being able to figure out patterns.
Yes. Sorry, say that again. I missed you a little bit.
Yeah. So are you doing also comparative analysis between assets, kind of being able to see patterns of behavior between one area versus another area, or use type, if it's industrial, if it's residential, that could help you predict.
Yeah, that's a very good question. So the sensor itself is asset type agnostic. So it actually works for different types of transformer, from the one you see on the electric pole to a substation or even in your manufacturing facilities. But that's exactly what we are working on now, the focus for this year. So we start to have the first paying pilot and more pilots in the pipeline. The idea is to test the solution in different types of environment to validate the accuracy of our solution. So you're totally correct. That's the focus now before the full commercialization in the next few years, to confirm that in what type of environments the sensor may work the best. And the idea is that with our very robust sensor and the AI analytics platform, it can be a very robust solution for all kinds of environments.
Right, right. Interesting. What is one failure you can catch with this technology earlier compared to the old technology or the current technology?
Yeah, so that's a great question as well. We actually really shine at very high frequency failure, something such as partial discharges, arcing. So these are the failure, basically meaning the electron leaking from the conductor, and we have start to have, say, insulation failure in any type of electrical equipment. This is the type of failure that can turn the asset into fire events or catastrophic explosion, but take a very long time to develop. And because of the high sensitivity and the amount of data we can collect with our sensor, we're able to pick up very high quality information from this type of events very early on. So we've proven that compared to the incumbent solution, for example, the CT, HFCT sensor, we are 10 times more sensitive and capture 5 times more data, which translates to even 9 to 12 months earlier detection than the traditional CT sensor. So the type of insulation, high frequency insulation failure, that's very finicky to catch, but happens at very high frequency, takes a long time to develop. I think that's where we really shine the most with this solution.
Right, right. Interesting. And what is the biggest challenge to install this technology in the real world?
Yeah, so the good thing is the sensor is non-invasive, but definitely on the product design side, we are also learning that how can we make an installation in the, say, the big transformer in the substation or the transformer on the pole very easy. So that's something we're working with the customers on. I would say because the transformer locations are usually not easy to access in the grid, so that just makes it difficult to install. But the one that's, say, sitting in the manufacturing sites or data centers, those are the one that's such that can be accessed easily compared to the other assets in the utility grids.
Right, right. Very interesting. So changing a little bit of topic, how did Apple or Meta prepare you to be a founder?
Yeah, I'm forever grateful for my experience in Dow Chemical, Apple, and Facebook because I think they really helped me in, I would say, two different aspects that's very important to the founder. How to de-risk. First of all, be very creative, resourceful when it comes to product development. I think even in Apple, Facebook, oftentimes we are facing very challenging technical problem and sometimes without a lot of resources in the very early stage. How do you use existing resources to prove that this problem can be de-risked, and how to build that roadmap to effectively de-risk a very difficult technical problem in a short period of time and limited resources. I find that to really resonate with my experience building a startup because we are really introducing a new innovations to the market with very limited human resources, financial resources. So how we can, de-risk and scale. That's something I think the Apple Meta experience was really helpful. Of course, the second big category I would say is definitely the leadership. I grew my team from nothing to 10 people in Apple so quickly. And that experience just really taught me on how to, first of all, think about the type of team, the type of people, the culture you want to build and cultivate as a leader. And from there, how do you and what do you do to attract the people who you want to hire who share the same vision and culture? That's something I think another important thing about building a startup. Because I think many people know that startup fails because of a few major reasons. One of them is the team. So how do you make sure you know the type of culture, the type of team you want to build, and more importantly, find the right tactics to attract and hire these type of people and keep them in the team.
Right, right. Amazing. Um, yeah, I think that those experiences are great because with if you start a company from nothing, you are going to make more mistakes, but you have limited resources,
Yeah,
so that
yeah.
you're out, right, and learn. So and you have a runway that you're going working with. So you have a very limited amount of moves that you can make, right? So it becomes much more important
Yeah,
because
yeah,
that way.
yeah. Exactly. I find that in the early stage for any startup, having a compelling product that resonate with the customers, which requires a lot of iterations and execution, fast execution, and and that relates to a strong team. Without a strong team, it's
Right,
really hard to have great execution. So I think the two really goes hand in hand, and that's where my Apple Meta experience just becomes so valuable for my founders' experience.
right, right. Yeah, that I think that's amazing. Um, so you 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 also had experience with AR and VR, right? Is that on the material side, on the software side? Can you tell us a bit more about your experience?
Yeah, it's on the material side. I was trained as a material scientist. I joined both Apple and Meta to help them develop new display materials for their Apple Vision Pro and also future products and the VR products. That, yeah, that's my core responsibilities.
Right. Yeah, I find that amazing. I mean, it's a shame that it hasn't became so popular as, a few years ago, people were talking about AR is the future, and it kind of didn't, didn't scale as, you know, we we thought it would, right?
Yeah, but I think that experience was also a great journey for me because actually all these companies actually spend a lot of time doing customer research and demo. They try to really understand, how this new technology and ecosystem can benefit their existing or potentially new customers. So in fact, when I was in Apple and Facebook, we spent so much time as a engineering manager and program manager, I spend so much time not just on developing the technology, but also really working with the product team to understand what is the potential use cases and how does that impact the customers, the users, and why. With that context and understanding, it really helps us who are providing the fundamental components for all these important products to make them to reach the specification and the requirements for the target user experience. So that's a great experience. I'm still hopeful on, what both companies can do with AR and VR, but I think that product experience translating user requirements to engineering specification, that really benefits my founder's journey as well.
Amazing. And you're also an angel investor, right? Can you tell us what do you
Yes.
look
Yeah. So my parents are very successful entrepreneur, and I'm also working with them to invest in next generation hardware, deep tech founders. So we do invest in around 25 to 50K check in the very, very early stage in this type of companies. We usually look for the founders who are not just technically sound, but they also know why they're building this at the personal level and also from the market perspective. I think the founder who has that technical expertise, acumen, and also the business side, the business understanding of the market and what the potential customers want and how to get there quickly, even in a hardware and deep tech product development environment. I think that's what we're looking for, someone who has a very good balance of technical expertise and the business acumen. So it can be from one single founder or a team of very founders with very complementary skill sets.
right? Right. Yeah, I find very interesting. The angel investment is I one of the things that I appreciate the most about angel investors is that they're giving back to the community. It's not only the investment; it's also the coaching, the support. Is finding smart money becomes much more important than the cash, right?
Exactly. I think that you are pretty spot on that because that's what I think all of us are feeling great about this angel investment efforts. It's not just about the financial right support. I think how we can partner with the founders and support them when they need the early stage investors from strategic planning to even team building, everything. Right. So I think that's a very rewarding experience and partnering with these founders to see them grow over the years. Even though I've only been doing this in the past 3 years, it's already just such a very rewarding experience to grow with the founder and see how the business go from nothing to something. So one very good example is Taya. So actually, it started with three of my classmates in Stanford, and they started working on copper recycling, and then pivoted so many times, and now they're doing this AI wearable, AI necklace, and recently Elena finished a fundraising and Andreessen speed round accelerator. Yeah, it's just amazing to see how the team went through this entire journey with such a resilience and perseverance, and how we can support them throughout the journey is just a very interesting and rewarding experience.
Amazing, amazing. I think that's a beautiful story. Yeah. The it having I mean it's hard enough to build something out of nothing, right? And then having a team that can support you, give you encouragement, that is a game changer in my opinion.
Yeah, exactly.
So talking a little bit about climate, what is one climate or energy trend you're excited about?
Yeah, I think everyone is hearing about data center and how it's competing the power demand, right, with everyone else. So I'm very excited about the behind the meter firm energy, the alternative firm energy from, say, the small modular nuclear reactor to geothermal to even just solar, wind, and battery storage, how all these alternative energy sources and the energy storage assets can help us have a more resilient energy supply and power grid. I think that's something I feel we're very excited about.
Right, right. Yeah, I think that's amazing. I have you heard about the nuclear power investment they're doing in Argentina just for the data centers?
Not really. Yeah. Okay.
So Argentina had a nuclear power station for I don't know 40
Uh-huh.
years, 50 years, something like that, right? Um, and the government decided to stop investing in that technology. So there were
Hmm.
two big ones, Atucha 1 and Atucha 2. Um, Recently, I think less than a year ago, they announced that they're going to invest heavily on atomic energy to power the future data centers for AI. So I think that's going to be very interesting to see happen. Yeah.
Yeah, I totally agree. And there's also geothermal, all
Right.
kinds of new, alternative energy resources. So just, very excited to see all these coming together.
Yes. Yes. That way we can have an array of different type of energies, and once we have energy abundance, then the data centers can leverage that to have more
Exactly.
reprocesses. So
Yes, exactly. Yeah, I
you
do.
know,
Yeah.
go ahead.
I was just saying that, that's why, and I think that extends to residential as well. In addition to the industrial data center setting, even in residential, people start to have solar and battery storage in their home. I think that will also help stabilize the grid as well. For example, we actually invested in a company called Raya Power, Raya. Their product is a battery storage system that you can put in the backyard. And that's also something that can help people, especially underserved community, using this very affordable solar battery to get more affordable energy.
Yeah, we're back. So, so what advice would you give to a younger self before your PhD or before your first job?
I would tell myself to be bolder, be more courageous than pursuing risk. I think I do have to say I was feeling because PhD was very uncertain. It's a very difficult time for many researchers, right? Uncertain, and of course the salaries is not great. So I was pursuing stability right after PhD, and hence I went to the corporate world. Looking back, I think with my research and backing the PhD and the energy, definitely could have contributed a lot to entrepreneurship and build some very disruptive technology that makes an impact to the world. Yeah, so if I would tell myself to just be bolder and to pursue something impactful.
Right, right. Amazing, amazing. So we're running out of time, but I truly appreciate it, Joseph, being you here today. We learned a lot. I think that you have a lot of potential with Magnify. I'm looking forward to see where you take the company next. Any final remarks before we wrap it up?
Yeah, I just want to say thank you, Vitrico, for hosting me. Really enjoyed the conversation. It's always good to share my experience and story, and hopefully it can be a motivator for many young entrepreneurs out there to make an impact to the world. So thank you.
Thank you.